All right, looks like we got a good point. We can begin our next workshop session. I'd like to welcome everybody back to this third workshop session here right before our holiday. Thank you for being here. Just going to start out here. We'll pick up pretty much right where we left off on the last session with where we had our parts with all of our gates and risers cut off. And I'm just going to show you one quick operation that I left out before we get into our little bit more refined machining for robot programming. But just to start, our finishing operations. Right now, as you know, we're doing our part to process operations where we're handling our part with our robot and bringing it to separate machines. And as we had just finished, we had cut off all of the gates and risers from our sample casting. Today, we're going to be mostly focusing on our process to part operations. So our part is going to be static, and we're going to bring tools with the robot to do operations on our part. But just to finish off our part to process operations, we're going to do a quick thing where we're going to reuse some of the stuff we've used in our previous session. So if you have your cell from our previous session, particularly if you have the cell that we use for our grab operation, this will actually work pretty handily for us. So if you bring up that operation, we can now actually create a place program. So because we already have all of our targets that we used for our initial grab operation, we can now set up our place operation or our place operation using the same things that we used before. So in this case, we're just going to reuse our targets. We're going to hold control and then click on our grab 3, then grab 2, then grab 1. So you'll have those operations selected, and that's the order they're going to go in. Then you're just going to hit the create program icon, and it's going to create those 3 points in the order you see on the right. Just by having those 3 operations, you'll have basically the exact opposite process we took to grab that part. So instead of coming in from the side, going in and grabbing our part, and then lifting straight up, we're going to come straight from above, go straight down onto our place location, and then move out of or pull back. However, with just these commands, it's going to still be holding our robot's still going to be holding our part. And to avoid damaging our part or our fixtures, we're going to have to add some extra actions to make sure this all works out. Just as a precaution before you start, make sure part frame 5 and pinch gripper assembly are active tool. As we were working with our cutoff and for both our gates and risers, we were using different tools and different part frames. So the important thing to do here is to make sure we're in those frames before we start making the program. When you create your program, it will default to using the part frame that your targets are under. However, you're going to have to select a different tool, in this case, our pinch gripper, to make sure we're using the exact same one that we used for our first picking programs. All right, and then so that our program will allow us to let go of that part, we're going to basically do this in 2 steps. The first thing is we're going to add something in our simulation. So our event instruction, similar to how in the grab program we attached our part to our gripper. Here we're going to want to detach. The thing you're going to make sure of is that we select the part frame 5 so that we're placing it exactly where we picked it up from before, and that it's still on that part frame 5, which is located in the corner of our part on our easy to identify and locate location, so that when we use our new robot, it's going to be in that same expected location. Once you have that frame selected, make sure it's from your pinch gripper that we're dropping our object, since it's going to be held by that object. We can then use or select our event instruction with that detach object option, and then hit OK to create that action where it will release it onto the table in our simulation. If we want to actually release it in real life, we're going to have to add an IO instruction. So here we're going to add an IO instruction where we're just releasing the gripper. So setting our IO number 9, our digital output 9 to 0. That's going to send the signal to our gripper to release or to open the jaws and release our part. And then the same as if we would do for our pick operation, we're also going to add that 2-second pause after that operation. So that just allows our gripper time to open, and it makes sure that our part is not, our gripper and our robot are not moving while we're letting it go. So after you have that 2-second pause, your part should be released and it should be ready to move away. So then once we have that set, we're going to set up all of our feeds, our speeds and roundings for this grip operation. The nice thing is we can just copy and paste these instructions from our first program. So we're going to use that same set speed and smooth for all of our movements away from the part. So we're going to set that smooth of 10 and set speed of 1,000 millimeters per second. We can just copy and paste those two instructions from our grab operation and paste them into our place operation. And then in the end, you'll also grab your 50 millimeters per second, our accurate movement, and paste that in right before our place operation. And then we're going to add those same smooth and fast speeds right after our move away from the table so that our robot is able to move on to the next step quickly. In the end, it'll look like the image on your right where you have those quick movements and then slow movements following. All right, so now you have your part back on the table. That's great. Now we're going to move on to our process to part operations. So if you're using that trial version of Robotic, it allows you to use a single robot in your cell. In the cell we have set up here, we actually use 2 robots in the cell. But for your version, all we need to do is just open up our second robot cell. So you're going to have to go into your at the top of your screen, you'll have to go File and Open, and we'll open our demo station spindle. In this case, it's going to be our robot that has a machining spindle or a spindle that can hold machine tools that we're going to do these next operations with. So when you open up this cell, you're going to be brought up with a cell with our yellow Fanuc robot instead of the white Kawasaki robot visible in the cell. And in this time, we're going to be using the exact same parts. So what we're also going to do is if you have your list of files for this demonstration, you can select and then drag our 2 .step files for our parts and drag them onto the same part frame 5 that we used in the previous cell. So that way everything's located exactly as it was in the former cell. All right. And in this case also, what we're going to want to select is we have multiple tools on this robot that have multiple tool profiles. For this operation, we're going to be using a grinding pad to grind off the remains of that riser stub. And so in this case, we're going to select our tool number 5. So if you right click on tool position 5 and then set that to our active tool, that's the tool we're going to be using as we make our points for this grinding operation. And then basically just to start with this robot, same as we did with our gripper robot, we're going to make an initialization program. In this case, our initialization is going to be bringing our robot to our home position, and we're going to be turning on our spindle so we're ready for all the actions we need to do to machine this part. So to start, we can create our home position. We're just going to be reusing the home position that's saved to our robot. So if you bring up that robot control panel, just by double clicking on the robot itself, or it's the robot in your tree, you should have the same image as you see on the right. And we're just going to select our home position from that tree. You'll see it's with the red box around it. That's going to bring the robot to our home position. And once in that position, we can press the create target icon, and now we'll have that home target. With this target, you're going to want to, you can rename this target. I'm going to recommend you rename it to home just so we know which target we're talking about. And I would also set it to a joint target. So that way our robot's going to move there regardless of what frame we're in. And then once you have that target, simply just select that target and then click the create program icon. This new program, we can name it to machine init or machine initialization. All right. So now that we have our movement set up, let's get all of our instructions we'll need to set up our spindle to start and to set it going to our machining speed. In this case, on our robot controller, we have pre-built programs. So one of the convenient things you can use while offline programming is a lot of the features that your robot includes already. So simple things that we can teach that are reusable over and over again. For instance, in this case, we're setting up a string of IO that are setting a control speed to our machining spindle, we have it set up so we can do that just via a program to a preset set speed for grinding on aluminum in this case. We also use this for similar operations where, say, we're doing tool picks or tool places, so that these are repeatable operations that are the same over and over again. We don't need to bother programming it into our robot cell. We can just simply simulate it as those pick and place operations for the purpose of location and estimating machine time. In this case, we're going to want to call this program from our robot controller, but not from our actual machining cell. So in this case, all we need to do, we'll select our create our program call icon from our tree, from our toolbar at the top, and then you'll select into our typing field, you'll just type in spin speed 2. So this way it will call the exact program that we have on our controller. So your names will vary, fonts will vary, but in this case, this is the name that we have pre-built into our controller for the program that sets our machine speed. In this case, the machine speed for grinding aluminum. All right. So now that you've set up that string of instructions to set our speed, we're also going to send the signal to start our machining spindle. In this case, it's going to be digital output 8. So if you select the IO call option from the top toolbar, you're going to then, in your pop-up menu, you're going to be setting your digital output number 8 to a value of 1. In this case, turning on the spindle. And then after our IO instructions, similar to as we did when we started up our bandsaw, we're going to add a 5-second pause to this instruction. In that pop-up window, you're going to type in 5,000, same as last time. Robotic defaults to you putting in the instruction in milliseconds, simply because there's a wide range of inputs that different robots can take. In this case, we'll be putting it as 5,000 milliseconds for our robot to be able to understand what we're doing for that weight. All right. So then you'll have now we have our instructions for how we're going to start our spindle. All we want to do is just set some speeds and accuracies, in this case, 500 millimeters per second with our rounding value of -1. So the same as you had done before, if you right click on your tool position, set instruction, and then select the set speed instruction, you'll then be able to create that set speed and then select 500 as its movement. And then after that, you can right click on your set speed instruction and then do a set rounding instruction. That way you'll be able to, when we do our machine initialization, our robot's going to move safely away to our home position at a reasonable rate of speed, and it will pause exactly where we expect it to stop. And then we're going to send the signal to turn on our machining spindle to the set speed that we want, and it'll be up to speed by the time we're ready to begin our machining operations. All right. Our next operation is going to be the grinding on the remains of our riser. So it's going to be sticking up a little bit from our part. In this case, we're going to use a Teach Target on Surface tool. So one thing you may notice if you select the Teach Target on Surface tool from your Program tab is that you'll have your settings as you might see on the right. We'll be able to select our edges of our curve. In this case, we don't want to select the center of our cylinder, just because that's not going to be a useful location for our machining. When you have when you're in your select Teach Target on Surface mode, you'll notice as you move your icon around on the part that our pad is actually tilted just a little bit as you're moving it around. This is just so we have a preset angle as we're doing our grinding operations. This allows us to deal with any unexpected features, say on this riser pad, if there's an extra bit of height. As we come across with this angled pad, it's going to be able to take any variation in that height without tearing up our pad or destroying our tool as we go by. One thing you might notice on this machining spindle, it has a linear compliance device attached to it. So in this case, when this machining spindle is moving along, it's only going to be putting some fixed force down on our part as we're doing our grinding operations. And then it'll be moving up and down to follow the contours of that surface, only putting the force that we've instructed on it. In this case, for this operation, we have it preset to 25 pounds of force for that pad, and that's going to be spread out over the entire area of that grinding pad. In this case, since we have an angled pad, it's going to be slightly less area than if we had our pad flush to the surface, but that's still going to be sufficient to get this finish we would like. Anyways, with our pad selected, what you're going to do is select the point on the edge of your riser, and it's going to be on the right side of that riser on the location right relative to the robot. As you'll see in our next slide, there's our initial startup position. And once we have this position, we're going to create a few extras as we go. So you should have part frame 5 active. And if you double click on our robot, you'll be able to bring up your robot control panel. And we're just going to be making these approach and retreat points just by moving the robot in a few different, mainly cardinal directions based off that frame. So in this case, we'll move up Z from our initial target location and then create our new approach point. And then we'll select our first target again to snap back the location. And then we'll move in our -Y direction. And you'll just move this pad in the -Y direction until you see it makes it clear of our riser. So you'll see right now it's angled up a little bit. We're going to want to wait until the back side of that pad clears the front of that riser. And then you can create your new point for the end of that grinding operation. Once you have that new target, the next step is simply to move your robot up in Z. And if you're having any trouble seeing exactly how far you're moving with each of these steps, you can simply hover over the direction you want to move it in on your robot control panel. And if you simply scroll your mouse wheel forward and back, it'll move that your tool in 10mm increments, just to get an idea of how your tool is going to move. And you can move it simply forward and back in that manner. And that's going to be a handy way if we're moving just past that riser pad. We don't have to guess at that exact distance. We can just move the pad some fixed amount forward in those 10mm steps and see where we land. Once you have that cut operation, you're going to move up Z. In this case, a similar distance in plus Z for our retreat point, and we'll create our fourth target there. All right. So now that you have that list of targets, we're just going to rename them. So selecting your first target that you made, it's going to be the second in our operation. So we'll drag that to be the second, and we'll just select it from there. So we'll have our first one that we selected, or our first one that we made with the Teach Target on Service tool is going to be our second step. And then it's going to be that retreat point that you made as the second operation. So you'll select them in the order that you made it. So it's going to be target 2, target 1, target 3, and target 4. And then you will rename it to riser grind in this case. So if you select all those operations, right click and then rename group, we can rename it to riser grind, and it'll put them all numbered in the order that they're actually going to be occurring for our operation. Now, to create a series of a series of passes, what we're also going to want to do is create an offset frame. So in this case, we're just grinding straight across the part, but it's going to take a few different passes to make sure we hit all the edges of our part and that we take off all the material we need in this pass. So we're also going to do, in addition to this, is we're going to create a new reference frame. So you'll hit the new reference frame button at the top of your toolbar. And then in this case, what you want to do is drag and drop that onto our turntable base. That way it's going to be always related to the turntable. It'll be in a similar orientation to our part frame 5. And we're also going to rename this one to our part offset frame. That way we know it's going to be the one that's not on our part, but we're going to be using to create some new passes and what offsets we're going to be using for each of those passes. If you double click on your new frame, you should be able to bring up where it is in space with all its details. In this case, we're going to want to just set it to be off of our part frame 5 in the direction that we're going to be doing our pass. So in this case, you're going to click on the reference position with respect to, and then we'll select part frame 5. That way we can see where it is in space with respect to part frame 5. Now, when you create that new target, it throws it into a location in the cell relative to where you are in the cell, relative to your cell frame. So it's going to be some point in space not related to part frame 5. We'll just set all of our values to 0 to start. So that way it's going to be located directly on part frame 5. And then what we'll do is we'll just simply change the location of our part 25 millimeters in positive X. That way, when we do our machining on this part, it's going to be shifted just a little bit in that direction. So it's going to be a 25 millimeter pass to the side. All right. So now that we have our new offset frame selected, we can start with creating our programs. Begin, you're just going to click or select your new list of targets, so 1 through 4. Select the first one, shift click on the last one, and then click the create program icon. It's going to be our first pass, so let's just rename it pass 1. It should look exactly as you see on that image on the right. It's just going to have your 4 targets, starting with a move J and move all L for all the other passes. All right, and then from there, we're just going to add some of our controls. So setting a speed and a duration for each of these actions. So to start, we're just going to insert a speed for when we're away from our part. So we're going to insert a set the instruction of 500 millimeters per second and a rounding instruction of 50. So that way it's going to move in wide arcs and very quickly when it's away from our part. And if you need to make this quickly, you can also just copy and paste this from our machine initialization instruction. All right. So once you're able to set your set speeds and your rounding to 500 millimeters per second and a smooth of 50 respectively, what we're going to do is just simply copy and paste that down till right after our second move. So that after that first move L, we're going to set our set speed and our smooth instruction. And this time we're just going to edit them so that they are at the speeds and roundings that we want. In this case, we actually don't want a fine movement speed simply because we're using a grinding pad. So in the case of the grinding pad, it's going to dig into the part deeper and deeper the longer it's dwelling on the part. And we don't want it to do a fine operation where as our grinding pad is moving through the part, when it hits a target location, it's going to pause in that location just briefly. And if it does that while we're on the part, it's going to leave a deeper gouge or a strange mark in the surface of the material, different than the rest of it, depending on how fast we are grinding away on the surface. So yeah, in this case, we're going to set to 30 millimeters per second as the grinding speed. So we're moving at an okay pace through the part and still removing the requisite amount of material. And then we set that rounding instruction to 1, just to make sure we're not going to be pausing while we're moving through our part. All right. All right. So now we have our new pass. So with our new pass instruction already set, what we're going to do now is actually create our different pass programs as well. So to make our new shift, or to make our new pass with that shift, all we're going to have to do is change the frame that we use. So in this case, we're just going to right click on our reference part, our set reference part instruction. So what you'll do, you'll copy, paste your initial program, that pass 1. You'll right click on your set part offset as the reference frame. And then from that tree, you're going to select part offset as our new reference frame. That way, basically, we're going to be going through the exact same operations we did before, but now everything's going to be relative to this new frame as opposed to the old one. And since our new frame is just shifted to the side 25 millimeters, all of our passes are going to be shifted in that same direction. And so now if we actually run our new program, you can see the tracing lines that happen. So as you're running Robotic, it's making those tracing lines. If you run that new program, you'll see the tracing lines are now shifted that 25 millimeters to the side, even though our old target locations remained in the same spot. So kind of in this way, we can make a whole bunch of new frames and a whole bunch of new instructions side by side without having to make a whole string of new targets to make this new program. We can make this much faster than if we were to just make new targets, and we're not cluttering up our cell as much as we would any other way. You can use this similar in many other robots. They'll often give you in their programming instructions the capacity to create offsets or tool offsets. It's a similar concept that we're doing here. In this case, we're just making new frames for those offsets. All right, so now that we have that first pass, let's create a new offset frame for our second pass. So in this case, we're going to create that new frame, same as before, drag and drop it onto our old location. So it's going to be onto the turntable base. And then we're going to just set the location relative to part frame 5, same as we had done before. So in this case, we're setting it relative to part frame 5. All of our locations is going to be 0 across the board, except for our X, where we're going to do a -25. So this way this pass will be actually to the other side of our initial pass and even further away from our second pass that we had made. And we'll rename this offset to offset 2, or part offset 2, so we can keep it straight from our initial part offset that we made. All right, so just some quick instruction that we have it. We can do the exact same thing that we did before with our first offset pass. So we'll copy and paste pass program 1 again. And this time, instead of swapping out part frame 5 part offset, the original one, we're going to swap it out with part offset 2, as you had done before. And this is going to create that same 3 passes. So now if you run that program, you'll notice a third set of tracer lines going through your program. And this is going to be the third pass of the robot. Now that we have all 3 of those passes, we need to get about a way of combining all these into one program. So one thing you might do on a robot is if you have some discrete step that you want to do over and over again, you'll have some program on the robot. And if you ever need to use it on your robot, you'll create a call operation. We can do the exact same thing here in our robot cell, similar to how we did to call that set speed instruction. But so long as we're working with programs within our offline programming cell, all these instructions can be uploaded to the robot as just a batch set of instructions, instead of having to create, say, our set of 4 different programs. We'll just create one program that has all of our motion instructions, all of our frame setting instructions as one. So basically, to create our new combined program that's going to give us all this information in one discrete program that we're going to send to our robot, you're going to start by selecting that create program icon. So this is going to create just a brand new generic program. So to start out with, I would just rename this one. We'll rename this one our combined program, or just combined. That way we can keep track of it in our tree. With that new program, so once you have it, right click on it, rename it. We can start basically creating our combined program. And we're going to do it the same way we did that program call for our spindle speed setting instruction. So in that machine initialization step, we called a program call that wasn't in our cell, but it is on our robot. In this case, we're going to be calling all of our programs that are in our cell itself. So to do that, we're going to hit that same program call instruction at the top of our toolbar. It's going to bring up a same dropdown you saw before, except this time we're going to hit the program call. We're going to click on the program call button, or select program button. In this case, we're going to start with selecting machine init, or machine initialization step. So that way, before we even start our operation, our robot's going to be safely away from our part, and we're going to have our set speed already given for our machining. And that's going to be our very first program. Now, we can't just go ahead and keep adding and adding and adding. Just one weird quirk of the Robotic software. We have to do a little bit of editing to allow us to keep adding programs one after the other, but it's a very small step. So in this case, you're going to, once you're brought back to your program call screen after selecting machine initialization, all you need to do is click on the space after your machine initialization call and hit the enter key. That's just going to move you down a row, so it's ready to accept a new instruction. And then we're going to continue to enter the rest of our program. So you'll press the select program button again. And this time you're going to select pass 3. So that was our pass that was in the other side of the center of our riser that we created last. And then after you select that, you'll notice when you go back to your add program call screen, it's going to have pass 3 added right after machine initialization. If we had not done the step of pressing the enter key, instead what you would get is your machine initialization step will be replaced with just pass 3. So by hitting the enter button, it allows us to create a string of these inputs one after the other. So now after that, we can then continue on, select the select program icon again. This time we'll add pass 1. And then after that, we're going to select program icon again, and we're going to add pass 2. So that we have our 3 passes, each with using that exact same string of targets, but this time we have it related to our part in space, and it's going to be to the left and right with those passes continuing in sequence. All right, so the final operation to make sure that that program is ready to roll, we're going to have to add an instruction to turn off our spindle after we're done. So that way, after we've completed our 3 passes and we have our riser ground down to the level that we want, we're just going to add that set IO instruction, and we're going to set it to set instruction number, our digital output number 8 to 0. And that way we can turn off our spindle safely after we've done all of our passes and the tool is retreated away from the robot. In this case, you're going to move, it's going to move up and away. It'll send that instruction and it'll stop our spindle. From there, I just want to check in with everybody. You should be able to have it very similar to what you see in the instruction here. You're going to have the robot perched just away from your part, and you're going to have those 3 passes visible as those tracing lines. And it'll have moved from its initial starting position of that home position down onto our part. In this case, you might have noticed that there's some weird naming instructions that were going, or naming conventions that were going on as we were going through our part. You might see from our tool position, we have them all labeled tool positions 1 through 7, and then a tool 11, which might seem a little odd. Positions 1 through 7 are just the naming conventions that we're using for naming each of these tools. So when you're in Robotic, in this case, if you were to name it all one thing, say tool position 2 without spaces, whenever our robot is going to have these positions called out to it, it's going to be calling out to a default tool location. In the case of Robotic, it's tool frame 9. But for our purposes, we want to use the tools that we have built into this cell. So in our case, we're going to be selecting, if we put that space in there, when we select tool position 5 and our robot calls tool position 5, it's going to be calling tool frame 5 on that robot. So in that way, when we're sending instructions through our robot, we don't have to be resetting a frame every time. We can start to reuse all the instructions that were taught to that robot. So say if we ever, say bent a tool or replaced a tool and we had to get a new position of that tool, say, somebody was putting a new machining bit into a collet and they didn't get to the exact same height they did last time. When we do the same tool setup operations we do out on our robot, we can just recycle that information here in our robot cell without having to type in that information into the robot cell as well. So we're just going to be calling information from our robot as well. Similar to how we have our part frames named down below, you might notice we have U-frame 2 called out directly. So if anybody has run a FANUC robot, you might understand that U-frame is the user frame that would be used for a FANUC robot to call out our user frame 2. And that is what it is using there. In our case, we also called out part frame number 5. Now we call it that simply because that's the frame that the robot expects for our part location every time. That is the frame that we taught on off our fixture where our part's going to be butted up against, and that's the part frame taught to the robot so it knows where it is in space every time. This is handy. So if our robot cell is already set up for everything to be located in space, that's great. We're not always going to be able to identify locations with the accuracy we want in Robotic or off of our 3D CAD models. So sometimes what we will be able to do is with our robot, we will locate our part in space and then call out, say, part frame 5. In this case, part frame 5 is going to be set by that robot using a simple frame teaching method, say touching off on 3 points, or it can be used with vision software if you're going to be using more elaborate setups where we need to locate parts in new locations every time. Either way, we'll be getting that location fed to us live by our robot every time. And this way, when we're setting up our frames from part to part, we have that frame setup located off that key location. And then with that key location, Robotic is just sending everything relative to that frame. So all that's relative just to the new location the robot knows and not always to the location it's simulated in the cell. That way, as we have, say, part variation or small changes where our part is fixtured over time, all we have to do is simply update those frames on our robot, and that information is going to be linked to the programs we send to the robot every time without us having to update our offline programming cell. You can also set up your robot to be linked to our robot cell, or we can start importing all this information just live off our robot. However, that's not a necessary step, and it's something we can just do offline here, and we don't have to rely on a direct connection to our robot, say while it's running, to update our information live every time. We can just rely on those locations that are taught to the robot, and then we'll feed our programs to the robot, and then it'll update that live for information on the robot itself. All right. That concludes kind of just that basic operation that we did with our process to part operation with our robot. In this case, just the riser cleanup. However, we can do a lot more complicated operations with this particular cell. You can do a little bit more contoured following programs, say around the outside of our part. However, we can do those similar things with our process to part operations. In this case, we're just using this to show off some of the stuff we can do with a robot spindle. In this case, this particular operation, that grinding operation, is unique to the robot itself. However, if you were to, say, be using machining tools, say an end mill or anything else, you could do these exact same operations keying off those locations. Our only real difference here is because we have that compliance device on our robot, we're able to ride up and down on the surface. So we have, say, as you might have noticed, the angled tool to start, where it's going to be following the contour of our part. That's something you might not be able to get away with regular machining tools, where you'll keep it level to the part and perform the cut at the angle you want. Just one thing to keep in mind, in our case, we're using a grinding pad to remove this mass material that we'll have on our riser surface. The reason we're using that grinding tool is simply to help match our tool to the robot. So in the case of our cell, we do have machine tools in this cell, which can be used for finer finishing operations. However, one thing to keep in mind when using those tools is you have to keep material removal rates quite low, even if your machining speeds are high, simply because the robotic arm is not as rigid as traditional machining centers or mills. The robot arm has a lot of reach. It also has a lot more looseness in every joint. And in this case, there are 6 joints as opposed to, say, 3 axis in some mills or operations. So there's a lot of potential for a lot of backlash, a lot of slack, and a lack of rigidity in your arm. And in that case, you're going to get a lot of tool chatter if you're using traditional machining tools over, say, the grinding pad used in this operation. However, those tools still can be used, just with extra considerations of slower feeding rates as opposed to the deeper and faster cuts you could make with traditional machining tools. Anyways, that concludes the lesson for today. Our next session for the workshop is going to include a little bit more elaborate talk into how we're going to be programming this in real life, some of the extra design considerations you'll need to take into account if you're doing offline programming for casting finishing particular, or just machining operations in general with a robot, and also some of the more advanced tools you'll get into as you're getting away from, say, just this demo version of Robotic. There's greater tools you can start to incorporate, particularly as you get into things like machining or following complex contours that you can only really do if you have a little bit more advanced tools at your belt. However, for today, this is kind of a great introduction just to some of the basic operations you can do with offline programming, and get a little bit of practice of how, if you're using an individual cell, how you be able to use some of those parts. You might have noticed we never used our combination wheel to the side. We'll use that a little bit more next time as we get access to more of those advanced programming tools. Beyond that, I will ask now if anybody has any questions about what we covered today, or some of the stuff we might cover in the next session. If you have any questions about casting finishing in general, please feel free to ask. All right. Looks like there's no questions for today. In that case, I'll thank you all for coming in to join this workshop session. And everybody have a happy 4th of July tomorrow. It's gonna be a great day, I think, for some of us. Beyond that, I'll see you guys at the next session next week for our concluding session, where we're going to get into a little bit more details on casting finishing itself and some of the extra considerations to have in. Until then, I'll see you all later. Have a great week. Bye.